This is a short tutorial on how to use LensKit to design a lens. From the home screen or your library screen, we would come down here and click the new lens button. In this screen, we're going to pick, for our example lens, a BK-7 lens, a pretty common material. We'll set the wavelength to 640. We'll set the diameter at 15 millimeters, center thickness at 4 millimeters. And because this is a smallish lens, we'll create a plano convex, and we'll leave the target focal length at 100 millimeters and create lens. And here's the lens. This shows a ray trace of the target, and it shows some performance variables, parameters below. In the upper left quadrant is wavefront distortion. By clicking this 3D plot button, you can see this wavefront error in 3D. It also provides a point spread function. Now, the wavefront error indicates there's some spherical aberration. We can try and reduce the spherical by balancing the focal plane here by clicking refocus. Now we can see the wavefront error is balanced and at a minimum for this lens. Now if we look at the 3D plot, it looks much smaller. The total wavefront error peak to valley is about 0.25 waves. Likewise, the point spread function, here again you can see a 3D plot. If you click the little 3D plot button, in the lower quadrants we get spherical aberration and the spot diagram. And the spot is pretty small, 60 micron. And if we want to see what's happening to the spot shapes through focus, we can click the 3D button and it shows these through focus plots. Again, looking at the spot shapes going into focus, you can see the spherical aberration signature there. Because this does have a quarter wave of error, perhaps you want to aspherize it. To do that, we can come down here to side 1. Side 2 is a plano side, so there's nothing here to work on, but we could add a radius here and try to balance aberrations, but for this video, we'll stick with side 1, and we can add an aspheric component. Now you could add all 3, but let's just start with 1 and see if that's good enough. So we click this button to indicate we want to use it for optimization. Then we click the optimize button. And you might have to click the optimize button a couple times to make sure it's at a minimum. Once it's at a minimum, you can look at the parameters again. The wavefront error is less than 100th wave, and the point spread function is back at 1. This is pretty good lens. And if we look at the through focus spots, we can see that the spots away from focus show nice uniformity, which indicates no spherical aberration. And then at the image plane, it's less than 1 micron in diameter. That's a pretty good lens. Now to save the lens, if we want to save it, we can give it a name up here. Click this, and we'll call this BK-7 Aspheric. And we'll save it. Now when we go back to our dashboard, you can see it's in the library here. And if we want to work on it, maybe we want to change it back to a non-asphere, we can edit it again in the lens designer. And there's how to create a lens in LensKit. Thanks for watching.